I'm here to discuss very important topic of microprocessor, which is architecture of 8085 microprocessor. Eight zero eight five is an 8-bit N-channel metal oxide semiconductor microprocessor. It is a 40-pin IC package fabricated on a single large-scale integration chip. The Intel 8085 uses a single 5-volt DC supply for its operation. Its clock speed is about 3 MHz. The clock cycle is of 320 nanoseconds. The time for the clock cycle of Intel 8085 is 20 nanoseconds. It has 80 basic instruction and 246 ops code. This is the architecture of 8085 microprocessor. We will discuss one by one to the each block of the microprocessor architecture. First block is ALU. ALU means ALU perform the following arithmetic and logical operations. ALU in this architecture, ALU is a very important part of the architecture, which perform the arithmetical and logical operation like addition, subtraction, logical and logical or logical exclusive or complement, increment, decrement, left, shift, clear. These are the arithmetical and logical operations performed by the ALU. 8085 microprocessor have following registers. Here, six registers, one accumulator, 5 flag registers, 2 special registers. General purpose registers are 6, which are B, C, D, E, H, and L. These are 8-bit registers, which are responsible to store 8-bit data. If we use in these general purpose register in the group, we can store 16-bit data also, like B, C, like group 2, B, D, E, group 3, H, and L. These, when we use these general purpose register in the pairs, we can store 16-bit data. We will further discuss the one by one to each register. First one is general purpose register. As I will tell before, 8085 has 6 general purpose registers, which are B, C, D, E, H, and L. They can be combined as register pair B, C, D, E, and H, L to perform some 16-bit operations. The programmer can use these registers to store our copy data into the registers by using data copy instruction. The HL register pair is also used to address memory location. In other words, HL register pair plays the role of memory address register. Accumulator and pointer. Accumulator is an 8-bit register that is a part of arithmetic logic unit. Program counter deals with the sequence. The acquisition of the instruction acts as a memory pointer. Stack pointer points to the memory location in read and write memory called the stack. Instruction register. The instruction register and The decoder are considered as a part of the ALU. The instruction register is a temporary storage for the current instruction of a program. The decoder decodes the instructions and establishes the sequence of events to follow. Flag register. Flag register are responsible uh, to provide the state of the result. They are called zero flag, carry flag, sign flag, parity flag, auxiliary carry flag. These all are flags which are responsible to convey the data about the state of the result. Zero flag uh, denote the result is zero in accumulator, and carry flag denotes the carry from D7, and a sign flag denote the result is positive or negative. Negative. Parity flag represent the number of ones are even or odd. Auxiliary carry defines the carry from D3 to D4. If the sum is accumulated large than 8-bit, the flip-flop used to indicate the carry, called the carry flag, is set to 1. When an arithmetic operation's result is 0, the flip-flop called 0 flag is set to 1. These flags have critical importance in the decision-making process of the microprocessor. The condition of flags are tested through the software instruction. The true understanding of the flag essential in writing assembly language programs. The combination of flag register and the accumulator is called the program status word. The PSW is 16-bit unit for step operation. These are flag registers, address bus and data bus. Here are 16-bit address bus and 8-bit data bus in 8085 microprocessor, where 87 to 80, these are responsible for flowing the data and also address. They are used to lower order address bus as well as data bus, including the instruction during the earlier part of the cycle. These lines are used to as a low order address bus as well as data bus. During the later part of the cycle, these lines are used as a data bus. However, the low order address bus can separate it from these signals by using a latch. Thank you.